Okay. Okay, we are doing the practice quiz. So I don't know how we're gonna do this because anyway, I'll try to just do it on the board here, I guess. The first question is asking for the average value of a function. So they give us a temperature function. So the degrees Celsius is 360 over t plus 1 cubed. Okay. And so the average value is going to be, and it says, what's the average temperature between 0 and 2? So if you were to graph this, it would look something like this. So between 0 and 2, we're going to find the area, the integral. So you're going to go integral from 0 to 2 of this. And I hope it's okay with you if I kind of do this. Make sure you remember to divide by the interval for the to get the average value. So anyway, you got 1/2 of so this there's u prime, right? So it's u prime times u to the negative third, and so you have let's just pull the 360 out. If that's okay with you.
Yeah.
Hope you don't mind.
Yeah.
Is that okay?
Mm-hmm.
That's fine. Okay, and so this guy in here, so you have 180 times, so it's -2 over t plus 1 squared. And so you plug in 2, and you have -2 over what? 9 minus, plug in 0, -2. Are we all okay with that? And then so what do we get here? +2 and -2/9. So that's 18/9 minus 2/9 is 16/9. And how many times does 9 go into 180? 20 times. So 20 times 16 would be, do we have a mistake here? What?
Why is the -2 on top again?
Yeah.
That's a good
Oh,
question.
-2 beyond bottom,
Thank you,
you
yeah.
get 1 on top.
-1, thank you. Dylan, you're on fire recently, brah.
Yee.
Yee. Sorry about that.
There's some jobs.
This is a nice thing about free responses. Now, like if you made that mistake, you'd still get pretty much all the points. You get like a little -1. So if you set that up correctly and did that correctly, and then just have the 2 magically change position, then you'd earn most of the points. So where were we? Sorry. Plug in the 2. You get 9 times 2 is 18. So -1/18 minus -1/2. Is that correct?
Yes.
Okay. So this is actually going to be 9/18 minus 1/18 is 8/18. 4 times 180. So 18 goes into 180 10 times. So it should be 80. Sorry about the confusion. Are we okay with that?
Mm-hmm.
Number what?
What was the answer?
80. So we had 8/18 times 180. The 18 went into 180 10 times. In hindsight, I'm thinking, would it maybe have been better to keep the 180 inside? Would that maybe made this an easier calculation? Because you would have had 180 over 18 and 180 over 2. It's maybe a little bit more straightforward to calculate. Something to think about. So number 2 is just, you don't need any calculation for number 2. So given a particle that has a position function of x, a velocity function of v, and an acceleration function of a, which one would give you the average speed? So, sorry for the Twitch fans out there. If you have position function, velocity function, and acceleration function, how do you get average speed? Savage. Which one do you integrate? Well, so let's look at this. No. If you integrate the velocity function, by the way, how do we get average temperature? You integrated the temperature function, right?
Yeah.
How do you get average velocity? You integrate the velocity function, except I want average speed. So what's the speed? It's the absolute value of velocity. We feel okay about that?
Yeah.
And so between time 2 and time 5, okay, you have to integrate from 2 to 5 of the absolute value of the velocity function, and then you divide by 3. Are we okay with that? You sure?
Wait, where's the 1/3 come from?
Because
The interval.
the width of the interval from 2 to 5.
Oh, yeah.
So just quick little picture to go with that. Like if your velocity function did this, the absolute value would turn all this area positive. So basically turn that hump up top. And then you have to divide, the width of the interval is 3. So you got to divide by 3 to get the average value. Okay, so the it's asking us for which of these integrals represents the average position. So same setup. How do you get the average position? X average would just be the integral. This says from 2 to 9. So you go from 2 to 9, integrating the position function. And what do I divide by? 7. Do we feel okay about that? Some food for thought here. Let's see. What's that describing? Average speed. How about that? Average velocity. Okay. How about that?
Displacement.
Displacement. Good. How about, now here, this is average position, as we just said. This one you can maybe say is it's the average like distance from the origin, I guess.
Could it be total distance? No.
No, it would be the average. It would be the average distance away from the origins. This would treat all position as positive, which would effectively be like a distance from the origin function, but not distance traveled.
So what would be distance traveled?
If you didn't have a 1/7 here, this would be the distance traveled integral.
Okay.
What, I guess, causes the, like, what is it once, maybe I just, like, would comprehend this that well, but, like, so the 1/7 in the front, like, how come that makes it so it's not the total distance traveled?
Well, so like, look at this. This, you agree that this is the displacement?
Yes.
So then you agree that dividing the displacement by 7 gives the average velocity. So this would be the total distance traveled. So dividing the total distance traveled by 7 would be the average speed. Does that answer your question?
Yeah.
Okay, so the answer was, Alyssa, I really hope that I don't have to hear from you later. This is like confusing because I'm trying to explain it and you're like carrying on a full conversation. Okay. If you've mastered this, all these concepts, then that's great, but you still shouldn't be talking. I'm trying to vote. What did we say the answer was? We said it was C for average position. Next one. It's going to ask, what's the average temperature of this object over a certain time interval? And notice that's not a function that we know how to do calculus on yet, really. We don't know the derivative or integral. So which of these is giving you the average temperature then? Oh, sorry, I keep forgetting about wish I could show these both at the same time, but maybe I can sort of if I move this. Oh, dang it, sorry. Okay, I don't know, that might be, looks terrible. Sorry, bear with me here. Okay, you sort of see half of both, I guess. It's pretty terrible, but it's gonna have to work for now. Okay, so anyway, if your temperature function is 2 times the sine of t, then the average temperature would just be the integral of that function. So don't overthink it. Now it says between time 3 and time 7. So there's 3, there's 7. You got to put a 1/4. You got to divide by the area under the curve. So, which one's the answer? F. Okay, so this question says there's 2 expressions here that would describe the average velocity between 3 and 8, given that your particle has a position function and a velocity function. So if you have a position and a velocity function, what's one way to get the average velocity?
Take the displacement and divided by your interval.
There you go. Displacement between 3 and 8. So this would just,
That was D.
there's your displacement divided by 5. So that's one of our answers. That's choice D. What else could we do? Well, what's another way? What would happen when you integrate the velocity function, you'd get the position function, right? And you'd plug in the 8 and the 3. So you'd have position at time 8 minus the position at time 3. Okay? Do we feel all right about that? This would also give you the average velocity.
Why isn't it B?
B would be like the acceleration, right? This right here is the change in velocity divided by the time. So if you wanted the average acceleration, that would give you that. Yeah, these are all kind of like meaningful statements. Like this is the average position of the particle. This is the average velocity. For A, it's the displacement divided by 5. So that's the average velocity. And then this would be the change in velocity divided by 5, which is the acceleration. We all feel okay about that? Okay. Number 6 gives us hopefully you can see that. It's a graph, and it says, what's the average value of this function? So this one's actually pretty easy if you know what to do. The calculation's simple. Because how do I get the average value from 0 to 6? You integrate, and then do what?
Divided by 6.
Divided by 6. So, and then how do I get this integral? Area under the curve between 0 and 6. So you got to chop it up. This one is, maybe it's not as easy as I thought. To chop this up, you have to probably do something like this. There might be another way to do it, but so I've got, let's see, 4 there, 4 there, 1 in that triangle, 3 in that triangle, and 2 in that triangle. So my total area would be 9, 13, 14. So 14 divided by 6, 7/3. No questions? Okay.
There's 7/3.
7/3, yeah. And then make sure your answer makes intuitive sense. Like 7/3 is right around here. Does that like feel right? Like if you do your calculation, you end up with like this. Obviously that's wrong, right? Obviously the average value is it spent a lot of time between 2 and 4, and then some time between 4 and 1, and then some more time between 1 and 2. So the average value's got to be somewhere. 7/3 hopefully makes some sense. All right. Beware. your quiz, when you see these answer choices, that's a huge hint, right? What kind of shape is this? It's a semicircle. Just be aware, if this question pops up on your free response quiz, you're not gonna have those answer choices. So you gotta make sure you're not dependent on seeing the answer choices to get clued in that it's a half circle. So half circle, radius of 6, and it's what's the average value between 0 and 6. So the integral would be about a quarter of the circle. Oh God, sorry. Not cut out for this this Twitch life. So this area here is 9 pi. And what do I do with the 9 pi? Divide it by 6. Are we all okay with that?
Oh, I have a spare GoPro chest mount if you want.
That's so fun.
GoPro, that'd be interesting. Okay, so now there's going to be some questions about what's the area bounded between two regions. Okay, so this one, what's the area bounded between, so what are those two shapes there?
Semicircle and parabola.
Shifted down.
And so what do those guys have in common? They both have the same, the parabola keeps going, but ever understand how they cross at 3 and -3?
Yeah.
Does that make sense? Okay, now the trick here is if you try to set this up, now it wouldn't be wrong to say that the area is this. This is not how you do it though. Do we understand why that is technically correct, the best kind of correct, but also not going to allow us to get a numerical answer? Do we understand or not?
No.
We don't know how to integrate that. That term is not going to be easily integrable, okay? What we can do though is just find this area, right? That's half a circle. So that area right there, the whole circle would be 9 pi, so it's 9 pi over 2. Okay? And then we got to find this area, which is going to add this area on. So how do we find that area? Well, this area would just be the integral. Well, you can do, an easy way to do this one is just to go from 0 to 3 and then double it. And the integral is 0 minus the function. And do you guys see how doing 0 minus the function would give you 9 minus x squared? You understand that? Because by the way, I mean, 9 minus x squared looks like this. It's a mirror image, so you can just think of it that way too. In any case, what you get here would be 2 times 9 minus a third of x cubed. Sorry, 9x, sorry. You feel okay about that?
Wouldn't that be a 30? It should be.
Evaluate.
Oh, thanks, sorry. So, plug in the 3, what do we get? 27 minus, what's 27 divided by 3?
9.
So it's going to be 27 minus 9 and then minus 0. So 18 times 2 is 36. Now, what's the answer though? That was just the area of that.
And then you combine the 36.
Add them up. So the final answer would be 36 plus half of 9 pi, the third choice. This is another good one that for free response. I'm glad it's going to be free response because you can earn, you might make one tiny mistake. Say you just forgot to divide by 2 there. And your final answer is you show this work and you say it's 36 plus 9 pi, you'd still earn, you'd lose like half a point rather than lose all points. Okay, same kind of question. What's the area of the region bounded between these curves? This one we might not actually need any calculus for. Because what are the two shapes?
Circle, semicircle, and a line.
Yeah. And the line's going to, well, let's just look at the picture, I guess. Because the line's going to form something. Here's the semicircle. What's this value here?
8.
8. And
There's a y intersection and an x intersection.
then y equals 8 minus x looks like this. So the bounded region is right here. Do you feel okay about that? Now this time, it's not really addition we want to look at, it's more like subtraction. So what I'm going to do is do this quarter circle here, and then subtract away the triangle. So the quarter circle is 64 pi, that's the whole circle, pi r squared, divided by 4. Then I'm going to subtract away this triangle. This triangle is 1/2 base times height. So I'm going to have 16 pi minus 32. Any confusion there? No? Feel good? Okay.
Oh, I guess that, yeah. I was thinking that was negative area for some reason, but I forgot.
Yeah. Okay, area bounded between these two curves. Common theme here, you want to draw the picture. Here's y equals x. Okay, there's 2 root x. Where do those guys cross? A little bit of a guess and check here. I promise I won't give you an integral where you have to integrate between two like crazy bounds. 4. Everyone okay with that? If you ask the question, how does x equal 2 root x? Try 1, try 4, try 9. 4 works. Okay, so does 0. So my integral is going to be between 0 and 4. And it's 2 root x minus x. So this is x to the 1/2 power. So what's the new power of x?
1/3.
3 halves. You got to add 1 to it, right?
Oh.
Because the power was 1/2. Now it's 1
yeah,
over 3 halves. And I got to multiply this by 2/3. Oh, that's the 4th.
Yeah, that's
yeah. Sorry, my bad. I was fixated on the power first. That's kind of how I think about it. I go power first, and then I put the number in. But if you want to do it in another order, that's fine too. Okay, we're going from 0 to 4. So plugging in the 4, what's 4 to the 3 halves power?
4.
It's 8. 8 times 4/3 would be 32/3 minus, plug 4 in here, 16 times 1/2 is 8. And then when you plug in the 0, you just get nothing. So this is what this comes out to be. And let's see, 32/3 minus 24/3 makes 8/3. There's your answer, 8/3. Could you have just done the area under the square root curve and then subtracted the triangle? Sure. In fact, that's kind of what this is. This is the area under the square root curve, and this is the triangle. 8. It's a 4x4 triangle. Yes. Okay. No questions? Okay, area. I think for the sake of time, I'll just skip this one. If it stumps you, I can discuss it with you tomorrow. But it's the same setup. You draw it. It's gonna be similar to the other one where you can break it into triangles if you want, or write 2 integrals. Okay. I want to make sure I have plenty of time to discuss these with you. We can come back to 11 if we have time. So this question is, there's going to be some questions about making an integral with respect to y. So for this question, it's just asking what's the which of these expressions represents the area bounded between 2 root x, which looks like that, and 3 minus x, which looks like that, and y equals 0, which looks like that. Okay. So if you need to write this as a single integral, you would have to slice it this way. Does everyone see why that's the case? If you slice it vertically, you would need 2 separate integrals. Do you see that?
No.
Well, if you, what's wrong?
Keep going.
So if you sliced it, so here's the region. If you slice it this way, okay, well that's a section, right? That area would be the area of this curve.
Yeah.
And then you have a second section like that.
Okay, yeah, I'm.
So if it's free response and you would prefer to have 2 integrals or do this integral plus this triangle, that's totally valid. But if the question's phrased like write an integral in terms of y, then you're kind of forced to do this. And so what you do there is you rearrange the 2 equations. So so this equation, y equals 3 minus x, is the same as writing x equals 3 minus y. You feel okay about that? Okay, and then this curve here, to write y equals 2 root x is the same as writing x equals 1/4 y squared. I divide by 2 and then square both sides. Right? Because then what I'm looking at is like how big is each slice? Well, each slice has a thickness of dy and it has a width of this x value minus this x value. So it would be 3 minus y minus 1/4 of y squared. That's the width of each slice. And so my integral would be choice E. And do we see why we're going to a y value of 2? The bound is important because where do they cross? They cross when x is 1 and y is 2. Do we see that? So if I'm going this way with my integral, if I'm slicing horizontally, then I need to go from 0 to 2. Do we have any questions or do we understand?
How did you know this?
Because, well, so I started with this, maybe, and I said, okay, well, how can 2 root x equal 3 minus x? And again, I'm not gonna think too complicated about it. I'm gonna try really easy numbers. I'm gonna go, does can x be 1? Does 1 work? Yeah, 2 times 1 is equal to 3 minus 1. So, okay, so my x value where these curves cross is 1. What's the y value then? Well, if I plug 1 into either one of these equations, they both show me that y is 2. Make sense? So if your integral was going to go horizontally, you'd go from 0 to 3 if you somehow got it all in one integral. But we're going horizontal. We're going vertically, so you go from 0 to 2.
Can you go over how you get the 1/4 y squared again?
Yeah, so I started with this, the given. So if I divide both sides by 2, and then square both sides, that's how I got that. Okay. All right, so 13, like 2 of these expressions represent a certain area, a certain region area. What are they? So I mean, like 3 of them you can see are x integrals and 3 of them are y integrals. Are we okay with that? So it's probably going to be 1 from each. So just a heads up, guys, on your quiz, it's probably going to be phrased, it's going to be free response, it's going to be phrased like write an integral in terms of x and write an integral in terms of y that are both equivalent to describe this area. So just that's what you want to keep your eye open for. So there's a cube root function, y equals cube root of x. Y equals cube root of x. X equals 1. And y equals 2. Oh, y equals 2 is up here. So I guess I have to redraw it, don't I? You see the sliver it's going to be up there? Do it one more time. Maybe I should have drawn the x equals 1 and the y equals 2 first. Gives me some framework to work in. And then here's the cube root function. So do you see this little region here? Across, say across here. So here's the region I care about. Okay. Let's get our bounds. Let's do the x one first. It tends to be the easier one. What is this x value, you think? 8? You guys agree? When x is 8, they both have a y value of 2. This is 8. Okay. How about this? This is 1, obviously. But what's the y value? Yeah, on this curve, when x is 1, y is 1, right? And then what's this y value? 2. So we already know bound-wise, the y integral is going to go from 1 to 2, whereas the x integral goes from 1 to 8. Make sense?
Mm-hmm.
Okay, so let's go through it. And so one integral is just integral from 1 to 8. And I'm going to say this y value minus this y value. This y value is 2. This y value is the cube root of x, and then dx. So that's one of my answers. Do you feel okay about that?
Yes.
Okay, so that's talking about horizontal slices. Or, I'm sorry, I misspoke. Vertical slices, right? Each slice would have a thickness of dx, and it would have a height of this. And then if I go the other way, I would go integral from 1 to 2. How thick is each slice now if I'm making horizontal slices? dy. That's the thickness. Now, how wide is each slice? It's this x value minus this x value. What's this x value?
Y cubed.
Y cubed. So it'd be y cubed minus 1. So B was the x1 and F and F. We okay with that? We might not have time to get to every question. So if there's any more on here that you see, well, maybe we can, I don't know. It'll be tight. We can finish though. Okay, so 14 is very similar to that. Notice they're all in terms of y. So all you want to do for this one is draw the curve, of course. Are we feeling okay about drawing a curve like x equals y squared minus 4 and knowing it looks like this? Knowing that this is positive 2 and this is negative 2 for the y values. And this, of course, is negative 4. And then x plus y equals 2 looks like this. Okay. And then, so my area is this. Okay. First of all, what are the bounds of my integral? What's this upper bound? Positive 2. How about this?
Negative.
Well, I'm asking the question of if x equals y squared minus 4 and x plus y equals 2, what's the y value that's going to make this work?
Well, we know that.
It's -3. Because we know it's below -2, right? So the first number you should try is -3. We'll plug in -3, you get x equals 5. Plug -3 in here, you get x equals 5 again. So this point here is 5, -3. You feel okay about that?
Yeah.
So my integral then is integral from -3 to 2 of this curve. So remember, when you slice, what's this x value right here?
2. Oh,
2 minus y. Right? So it's 2 minus y. What's this x value?
why?
I'm running out of room, sorry. It's y squared minus 4. See, x equals y squared minus 4. So integral -3 to 2. So again, this x value is 2 minus y. And then this x value is y squared minus 4, and then multiplied by dy. So the final answer is f, because you've got 2 minus -4, which makes 6, and then you got your minus y squared. Is everyone okay with that? So then, we're out of time now. If you guys want to discuss these last couple tomorrow, that's fine. They're just pretty much conceptual questions. They don't involve any calculation, really. They're just like, which of these expressions would represent the area? So try to figure them out on your own. Hopefully they're somewhat straightforward. And then if you're still a little lost, we can discuss them tomorrow.
I have one question.